Hello, everyone. We are Group D, the last group. So thank you for waiting for us. So I'm Reza,
And I'm Yusuke.
and we're going to be talking about the same thing, but also our own solutions that we're thinking for this problem. So take it away.
Okay, so we will start our presentation titled Creating a Hydrogen Society in the Tohoku region. First, we want to clarify our answers to the question, can we create hydrogen society in the Tohoku region? And our answer is this.
Yes, we can!
Okay, so I explain our definition of hydrogen society. So we define it as a society that has readily available hydrogen energy and therefore use it as its main energy source. Also, it could be used in multiple applications, including transportation, industry, and residential. So I wanna go over the advantage of hydrogen in this slide. So first, it's abundance. We can use hydrogen for long period, and the second one is versatility. So hydrogen can store energy and can be used in multiple ways: vehicles, heating buildings, and generation of electricity. And last one is environmental friendliness. So it's zero emission of greenhouse gases if produced cleanly. So as you can see, there are many advantages of hydrogen. But however, there are some issues in hydrogen energy as well. So first one is social systematic challenges. So we have to get safety concerns, public acceptance, and global cooperation. And second one is technological challenges. We need to improve the efficiency or get to make low high costs and scalability. And we need to think about how to store and transport it. So in this presentation, we focus on the storage challenges. And one of the challenge we think is the size of the hydrogen tank. So as you can see, there was a small tank at Denso, but to realize a hydrogen society, we need huge tanks in the Tohoku region. And I want to explain the current storage method. So for now, they store hydrogen as liquid or gaseous, and those methods are utilized in hydrogen station or air industry. And the average size of the tank is around 100 cubic meter. So this is the current storage situation. And to realize the hydrogen society, we need to make it much bigger. So then we need to consider the location and cost of the tank and the risk when an earthquake occurs.
So just to touch more on this, we can think of an example of a tank that we all saw, or some of us saw, which is at Denso. They had two tanks, and each one was 19.4 tons. 19.6? 19.6 tons. But that's actually just the weight. That's the total weight, but most of the weight was the actual tank. If you look at the weight of the hydrogen, I think it was only around like 200 kilograms or something. 25 kilograms. Yeah. So, and then you have to think about this as well. As you know, Japan has a goal of becoming like using hydrogen and having a hydrogen society. And in 2050, guess how much hydrogen they want to like make and use. So, you know, since the tank has 25 kilograms, guess how much? They need to make 20 million tons. So that's kind of crazy, because if Denso only had 50 kilograms, how are we going to make 20 million tons? That's what we have to tackle now, which since all the other groups talked about utilization and transport, we felt like this would be a fitting topic to talk about. So these are our proposed solutions. We propose that the country as a whole, like in public and private sectors, do some research and really consider underground and undersea hydrogen storage. So underground hydrogen storage is not like a completely new thing. It's been done for like 10 to 20 years. It's called UHS. So UHS is a way to store the hydrogen gas in already like in existing places in the earth. Like for example, gas reservoirs where it used to have natural gas, or something called salt caverns, which is the way they do it is they dissolve the salt in the caverns, and then that gets rid of the salt. So it's just a huge place where you can store gas. This allows for large scale storage for hydrogen, which, as you can imagine building like thousands of those Denso tanks. Like that sounds insane to me. So we need to think of some other way. And I think this is like a really good way. It offers high storage capacities, as well as it's cost effective because you don't actually have to make the tanks and use this metal. Just to give you some numbers, this has been used in, I think, around Europe. And the capacity is about 2,000 to 6,000 tons. I think there's one in France, which is about 6,200 tons of hydrogen, which compared to 25 kilograms is like a bit better, right? So yes. To implement this in the Tohoku region, we have these 4 steps. First is geological assessment. So what we have to do is make these comprehensive field studies, which are like surveys. And we have to find out the suitable places to store this hydrogen in the Tohoku region. So actually, there was a paper studied about this UHS in Japan, but they only explored the Niigata region, the prefecture, and they found a lot of actually good candidates for that. So I propose that since we're in the Tohoku region, and since we have such a good university with good research facilities, that maybe some researchers in the Tohoku University can do some field studies as well in this area. Also, after that, we need to have collaborative planning. This includes government agencies like the Ministry of Economy, Trade, and Industry. Also, industry companies as well, like the Tohoku Denryoku, and research institutions like this university. After that, we need to focus on actually making the infrastructure. So, like I said, for salt caverns, this means injecting the caverns with water and dissolving it. There's also other places like the gas caverns, which is just looking for places where gas was stored before. And then we need to actually make sure that this hydrogen is well kept, because if you think about storing it in tanks, there's this thing called embrittlement, which a lot of you have mentioned. In caverns, there are other things that can make it not so nice. For example, there can be some bacteria or some sort of microbe life form which consumes the hydrogen. So we need to think about that as well. After that is the utilization. So this hydrogen can be used in many other ways, like you've mentioned before, such as fuel source or power generation or industrial processes. Of course, there are challenges. So there's the social concern, which is like possible explosions or something because of the hydrogen and water contamination. I think this, all of you may know, is not really that big of a risk compared to some other things. So we need to educate the public. I think in one of your presentations, the Japanese public thought that hydrogen is more dangerous than gene therapy, which is insane to me, but okay. So we need to educate the public. We also need to think about safety during earthquakes. So this can be resolved the way that Denso does it, which is using some like seismic detectors and also like safety valves and switches. We also have to worry about the cost of monitoring and inspection and repair. So obviously it's going to cost some money to invest in this, but the Japanese government invested 1.6 trillion yen, so they have the money to do this. They just need to put their focus into it. And also there's the suitability. So this suitability we don't know yet because there's no research, but even if there are like no suitable salt caverns, we can also consider this cap rock, which is another sort of underground thing that we can consider. Now, the second method or the second solution I want to talk about is the undersea hydrogen storage. This is sort of a more far-fetched idea because not a lot of people are talking about it, and not a lot of people are implementing it now since it's such a new thing. But it is being researched in Aberdeen in Scotland. So their government put in 150,000 like pounds into this thing. So this is something for storing. To put it in a nutshell, it's you take the tanks and you put them under the sea. And what this allows you to do is, since the ocean has higher pressure, you can have thinner walls. You can also save space because a lot of the struggles that Denso talked about was having taking up a lot of space. And if you're talking about huge tanks, putting them in the sea where people don't live is a good choice. Also, there's high safety because there's not going to be any buildings crashing down during an earthquake. It's just water. So, and even if it leaks, it'll just dissolve into the water. So that's not too bad. There's hydrogen in water, so it's okay. Yes, there are challenges to this, of course, since it's so new. It's going to cost a lot to have pipes, as you can imagine. Also, doing maintenance is really difficult, although it is difficult in general to maintain tanks. I think Denso said that they check their tanks 3 times a day, which is a lot. So doing that in the sea is challenging. Also, this might disrupt the marine ecosystems because we don't know how this affects the fish and all this life forms there. To respond to these challenges, we can actually do all of the work in the ocean or above the ocean as well, like have the floating turbines and produce the energy there, and actually just transport the electricity. Also, you can use the electricity for cathodic protection, which tries to reduce the corrosion. And to respond to the marine environment, this can be not mitigated, but made safer with proper surveys by like a marine biologist. So in conclusion, we need to get bigger capacity for hydrogen. We need to, and to do this, we propose underground and undersea storage. So to answer the question, can we create a hydrogen society in the Tohoku region? I say, yes, we can. Okay. Thanks for listening.